Okay, looking at quotient rule here. So our quotient rule is when we're looking where we have a function over the top of another function in a fraction form. So our rule for that is that y dash is equal to u dash v minus v dash u over v squared. So here we've got x squared plus 1 over 2x minus 3. So first step, I'm going to write u is equal to x squared plus 1. So my u dash is going to equal 2x. My v is equal to 2x minus 3. So my v dash is going to equal 2. Then I will write that y is dash is equal to u dash v minus v dash u over v squared. So I'm going to put in my 2x outside of 2x minus 3, take away my v dash is 2 outside of x squared plus 1, and on the bottom I've got v squared, so that'll be 2x take 3 all squared. I can then simplify what I've got on the top and see if I can collect any like terms, and then see if I can simplify with what's on the bottom. So when I expand it out, I'm going to get 4x squared, take away 6x, minus 2x squared, take away 2. Just be careful, we've got a subtraction there, so that applies to both of those. And then on the bottom, I've got my 2x minus 3 all squared. So on the top, I can collect those like terms, and that will give me 2x squared minus 6x minus 2 over 2x minus 3 all squared. I can see if I can do any factorising, so I can take a 2 out, and I get x squared minus 3x minus 1. And on the bottom I've got 2x minus 3 all squared. I can have a look at this one and see if there's anything that I can factorise. So I can go, okay, my AC is equal to -1, my B is equal to -3. Are there any numbers that multiply to give -1 that add to give -3? And nothing really obvious comes to light, so we leave our answer as that. And that's our quotient rule.